The purpose of this video is to learn about exceptions, and what I would recommend is that you have my lecture slides opened so that you can connect some of the material that we're going to learn in this video with some of the material about exceptions that has already been presented to you as lectures. That being said, again, keep this in mind that these videos are uh, not a substitute of the actual lectures. What is being presented in the classroom, okay, you need to attend those lectures, and once you've attended those lectures and you have studied, these short videos will hopefully help you to put some of these materials together and get a better understanding of some of the topics that we learn in class. So about exceptions, the best way to understand exceptions is, let's first get a little bit of a 2-minute kind of a primer on and a little bit of theoretical approach of this concept. So let's put this, at least let's put the title down. So what we're learning right now are exceptions. Okay, so what I've really done on my lecture slides is I've presented this short story where you actually have a developer. So you have some kind of a developer, and what this developer is doing is basically writing code. So you have this developer writing some code. Okay, so let's say I have a condition statement there, and he's writing some code, and this code over here is nothing but happens to be either in a .java file if it's a Java developer, or it could be a .c file if it's a C developer, or it could be a .cpp file if it's a C++ developer. And you get the idea that this is basically a higher level language that the developer can understand. But if you would like to get an executable out of this, if you would like to get some kind of a file that the computer can understand, that the computer can run, what you do is you take this file which is written by the developer and feed it through a compiler, which is another software. And think of the compiler right now from a very high level as something kind of a translator. Okay, so feeding this through a compiler, and what the compiler is doing is taking these files as .java, .c, .cpp, and it's producing something out uh, as a binary. It produces basically a binary. Okay, so the binary could take many forms. It could either be, let's say, if you're on a Mac, it could be a .dmg file, or it could be a .jar file, or it could be I don't know, .exe file, or it could be a .out file. And you get the idea that these executables are basically a set of files that you can start executing on your computer, and it will basically start executing this code that the developer has actually written. So what you now have is this entirely a new set of files, which is more specifically an executable executable files. And again, with the story that we did in lecture was that these executable at some point, maybe, I don't know, they might get packaged into again, I'm being a little bit old-fashioned here, but let's say this get packaged, I don't know, into a CD. So this is a nice looking CD over here. Okay, and so I have a nice CD over here, and I don't know, the marketing department might take this CD and put a really nice fancy box on it. So it'll say, this is my awesome software. So this is my awesome software. And I don't know, they might put a price tag on this. So they might put a price tag, I don't know, 49.99. And then you might have some store, which could be Best Buy, for example. Okay, so it could be Best Buy that would eventually take this product, put it on display, and then you as a user would come along really happy, and you say, oh look, I want to buy the software called Awesome, and you're going to give the Best Buy 49.99, and you're going to get the software, and then you take this software home, you take this home, and now let's say you take this home and you're going to have your own computer. So you have a computer at home. Okay, let's say that's your monitor, and this is your keyboard, this is CPU, and you take the CD, you put it on your CPU, and you start running the software. Okay, so why am I telling you the story here? The reason I'm telling you the story is that first thing, when this when this uh, when this higher level program, which is written in Java, C, or C++, gets fed into a compiler, and if there's a bug in your code at this point, and the compiler can catch that bug, it's basically called a compile time error. Okay, so if the compiler can catch anything, which happens to be some kind of an error, which could be a syntactical error, your code is syntactically incorrect. That's just one example of what a compiler can do. You're going to get something called a compile time error. So errors that are caught by the compiler are called compile time errors. Okay. Likewise, as you take the CD and you start running it on your computer, and if something goes wrong, now remember this user over here gets the CD and he puts it on into his computer, he starts running this program, and if something goes wrong during the execution of the program, so this is the keyword here, the keyword is if something goes wrong during the execution or during the runtime, meaning when your program is actually running, when it is running and if something goes wrong, that is called those errors more specifically are called runtime runtime errors. Okay, and when we learn exceptions, the whole idea is with exceptions is that we're trying to more specifically target the errors that happen during the execution of your program. We are not really looking at these category of errors. We are more specifically targeting these errors that might happen during the execution of your program. Alright, so with this 2-minute primer on what actually exceptions there are and what compile time and runtime errors are, we're going to take this idea and now going to start writing some code in Python that hopefully puts these things a little bit together. Alright guys, so what we're going to do now is we're going to start looking at this idea of exceptions a little bit from Python's perspective. So what I'd like to do in this video is walk through a very small example that would allow us to put these ideas together. So first thing regarding exceptions, there are two main pieces regarding exceptions. There's a point somewhere in your code when an exception gets raised, and there is some other point in your program where that exception is going to get caught. Okay, so remember these two pieces here. In order to use exceptions correctly, at some point, some piece of your code is going to raise an exception, it's going to throw an exception, okay? And there's going to be some other piece, a second part of your program that is responsible for catching that exception. Okay, so let me first put a little bit of this idea a little bit more concrete. So first thing, let's just put some generic code here. This isn't really right now really isn't Python code, but I just want to get the idea first. So let's say if you see some code which is inside a try except block, meaning you have the try block there and some code over here which will be the body, okay, and then you have something called the except block and some kind of an exception type in there. Okay, again, this is not really valid Python code as of now, but I just want to give you a generic an intuition first. Okay, so that could be some handler or some code within the except block. Okay, so what's happening here? What's happening here is so let me turn on my pen option, is that this entire thing over here, this entire piece over here, this entire try except is a code in your Python that is responsible for catching an exception. Okay, what does it really mean here? It means here that this code that I'm going to put inside the body, is the code that might, at execution of your program, might do something incorrect. What does incorrect mean in this context? Incorrect just means that that piece inside the body might raise an exception. Meaning something could actually go wrong during the execution of this entire block of code here. If that raises an exception, okay, so this is an exception point 1, then what I have here as point 2 is some ability to catch that exception. This is the whole idea with this except here. Okay, so this except is doing is going to catch that exception, whatever that exception type is going to catch it, and it's going to respond by having an appropriate code over here that's the response on what to do when that exception gets caught. Okay, so this is very high level idea. This is what Python does with connecting these two pieces here. Okay, so the first piece comes from right here. Some code might raise an exception. The code that raises an exception is right there as part of body. And if it raises an exception, if it does happen, then you need to have a correspondingly an except block that is responsible for catching it. Okay, so those are the two super important ideas. And now let's take these ideas and let's try to see if I can write some code that that will connect it to. Okay, so let's do this. Let's start with a really simple program first, and let's create a main function. So let's create a function. I don't know. Let's just call it main. Okay, let's just call it main just for time being. All right, and what I'm going to do first thing is I'm going to have a try block, and inside try block I'm going to say I'm going to take two numbers. I'm going to take number one and number two from the user, and I'm going to run. Let's take this from the user. So I'm going to say input enter two numbers separated by a comma. All right. So all I'm doing over here is I'm just going to ask the user that enter two numbers, and just make sure these numbers are separated by a comma, and I'm going to take those two numbers and I'm going to collect it as number one and number two, which are acting as my local variable. And then I'm going to take I'm going to take these two numbers. I'm just going to perform a simple division. So I'm going to take number one and number two, I'm going to divide it together, and whatever the result is, I'm going to store it in a local variable called result, and then I'm just going to say print whatever that result is. So let's just print whatever that result is. Okay. All right. Now, why do I have this? Why do I have this in a try block first place? Well, the reason I have it in a try block is that something could actually go wrong with this 3 lines of code here. Okay, what could go wrong with these 3 lines of code here? Well, there are a couple things that could go wrong, but the first most important thing that could actually go wrong with these lines of code is that the user could actually enter number 2, which happens to be 0, and I'm going to perform a division, which is a division by 0, and a division by 0 is incorrect. I mean, it's not mathematically defined. You cannot take a number and divide by 0. So something could go wrong. Something could go wrong with these lines of code that happens to be inside a try block. And if something does go wrong, I need to have some ability to catch it. So I'm going to say except, and let's just say 0 division error. If that really happens, then I'm going to catch it. And if I do catch it, then do I have some ability to inform the user to let him know that what is it that exactly gone wrong? So I'm going to say print, this is a division by 0 error. All right, so I'm just informing the user there that look, something has gone wrong, and I'm printing out the actual division by 0. All right, let's just keep it the way it is right now. Let's just keep it the way it is right now, and let's just run this this code here. All right, so so what I can do at this point is I can either make it as part of my main thing, or I don't even have to do that because I'm not going to run this from a command line. So let's do this. Let's just run this function as it is, the way it is right now, by calling the main function. Okay. All right, so let's do this. Let's take this code and let's just run this. So I'm going to click on learning exceptions.py. I'm going to right click this. I'm going to say run learning exceptions.py, and the first thing I get back over here is a message saying enter two numbers separated by a comma. So let's put 5, 6, and I get back the division between 5 and 6, which is 0.8334. Okay, first thing, did anything go wrong when the program was running? When the program was running, nothing went wrong because 5, 6, you can actually define a division by taking 5 and 6. Nothing went wrong, and because nothing went wrong, the except block never got executed. But now let's run this program again. Let's run this again, but making sure that something actually does go wrong there. So if I run this program again, and now if I pass in 5, 0. Okay, 5, 0. I'm trying to divide 5 by 0. Now that's indefined. That's not defined, and something did go wrong. But I'm trying to have a division by 0, and then at that point, this except block. This is a point when the except block springs into action, and what you now have is some ability to catch that error. All right, so let's do this a little bit more concretely. What I have, number 1 as number 5, number 2 as 0. I'm trying to do 5 divided by 0, and this is bad. This is really bad because I cannot do this. And now there's a time when the except block comes into action and says, oh look, something went wrong here. And when I say something went wrong, it means something raised an exception somewhere in this division over here. All right, an exception got raised, and because an exception got raised, I have some ability to catch it. And when I say catch it, all it means I have some ability within the except block to catch that exception and respond appropriately, telling the user what is it that actually went wrong by saying division by 0. Okay. Now, is that the only thing that could go wrong in this program that I've written when it starts running? But let's try. Let's run it once more. Let's run it once more. If the user enters 2 number, but instead of saying a comma, I don't know, I just put maybe a space and 1. What do you think is going to happen now? I want 2 numbers that are separated by a comma, but I'm entering 5 and 1 that are separated by a space. And now what has happened here is that something went wrong. And this is the error. This is the entire error that gets shown to you. And the error over here is that this is an unexpected end of file while passing, and there's a lot of jargon over here that is confusing to the user what actually went wrong. And at some point, Python even tells you the line number where things actually went wrong. And you see this is really complicated for the user to understand what is it that went wrong. All right, so let's take a step back. What I have is, this is my code over here. Okay, something went wrong in that code, but it wasn't really a division by 0 thing. It wasn't really division by 0. It was more something on the lines of some syntactical error. There was some syntactical error by the user that did not get caught. I did not have the ability to catch an error that was syntactically wrong. So what I'm going to do now is, I'm still going to tell Python, okay, look, these are the 3 lines of code. Something can still go wrong with that code. But there's something that could go wrong is something that is still not a division by 0 error. So now what I'm going to do is, I'm going to say that with this code, something can still go wrong, and let's say that could be as simple as a syntax error. It could be as simple as a syntax error. If that is the case, I'm going to say print something wrong in the input form. Okay, so I'm just putting a syntax error there, and let's just run this code again. So let's run this again, and now if I say please enter 2 numbers are separated by a comma, the user says 5 space 1, and now what has happened is the correct except block related to the syntactical malformness of your program gets caught, because 5 space 1 is not separated by a comma. So I'm telling the user that something is wrong in the input form, and I can tell back a little bit something more appropriately to the user what is it that went wrong, rather than the previous case where all that jargon was being thrown to the user. All right, so what I've done in this video so far is that I've shown you some kind of a mechanism on if an exception does get raised. Remember, exception is getting raised, it is getting raised somewhere over here. So if I open up my pen drawing here, this code over here, which is right there, and within that code, more specifically inside the year, right, if an exception does get raised, which is a division by 0, let's say this happened, a division by 0, right? Now remember, this is just Python code there. Within that Python code, which is this division thing, the folks that wrote the Python programming language, within their implementation of the division, they might be raising an exception if number 2 is here. I do not have to call that raise keyword anywhere. It is already done for me. The division method is already raising an exception. All I've done with this code is I'm showing you the ability on how to catch that exception, how to catch it. Okay, this is what we're concentrating on this video, was how to catch the exception when it gets raised inside the try block. Okay, all right, so I hope this was useful, at least the first part of this video, in understanding what how we going to put the 2 pieces together. And now let's do this. Let's make a slightly I guess let's do this. Let's just get a nice closure on this exceptions thing. I'm not going to get into user-defined exceptions because they are very well articulated in my lecture slides. But what I'm going to do right now is one small thing where I will write some code that actually raises an exception. Let's look at one more example that actually raises an exception. That might be slightly more beneficial. So I'm going to get rid of all of this code here, and let's start a class called circle. All right. So what's a circle? Well, a circle is a two-dimensional geometric object. So how would I create one? Let's have a constructor. So let's create a constructor. So I have a constructor that I'm just going to make it really simple. Let's just see that it takes in a radius, and it takes in a radius. And what should I do with this radius? Well, I could set it as my instance member. So I can say the radius. And let's do that right now. Let's keep things a little bit simple here. Okay, so what's going on here? So within the constructor, I take in a local variable called radius, and I take that local variable radius and I set it as an instance, set it to my instance variable, which is underscore radius. All right. Now, what I will do at this point is let's make it a little bit more challenging. Instead of setting it over here, let's just create an instance method. Let's just create an instance method, self dot set radius. Okay, I'll show you why am I doing this. Instead of setting it explicitly right there, let's just create a setter method. Let's just create a setter method called set radius. All right, so let's just create a setter method called set radius, and inside set radius, what I'm going to do is I'm going to take that radius that's being passed into it, which is this piece over here, this piece over here, which gets passed into it, and I'll take that local variable radius. I'm going to set a condition that if this radius is a number that happens to be negative. Okay, radius cannot be negative, first thing, but if it is negative, if you're passing me a number that is negative, all right, what you're doing is something incorrect. What I'm going to do now is I'm just going to tell whichever person who's calling set radius is that, look, you cannot pass me a negative number, and I'm going to raise an exception. I'm just going to raise an exception. Okay, this is a point where I say, look, this is wrong. I don't want a negative number. What I really want is a positive number. So I'm just going to give you back an exception. So let's just say a runtime error, and I'm just going to say negative number. Right, so I'm not creating a user-defined exception. I'm just using one of the exceptions that happens to be present in the Python's library, which is a runtime error. All right. Okay. But what if it's actually a positive number? Okay, so if it's a positive number, then everything is fine. And at this point, I can just say self dot underscore radius equals to radius. Okay, then I can just set it to my instance variable. All right, so this I need to get my local reference self, and there you go, that corrects it. Okay, so that's my set radius, and let's I don't know, let's just have a simple method that calculates the area of this circle. Get area, let's say get area takes in the self and returns back the area of my circle. So I'm going to just say return self dot radius, whatever the parameter of radius, multiplied with self dot. So I'm just using pi r square times the pi, which is inside my math module. So let's just say math.pi, and of course I need to import my math module. So import math, and I've got my math module over there. Okay, and let's now just define a simple, maybe we can just define a simple main function that puts the whole code in execution. So let's do this. Let's create a circle C1, which is a circle with radius of 5. Okay, now let's do this. Let's put this inside a try block. Now why am I putting this inside a try block? You'll see this in just a second. So I'm going to say print area of a circle is whatever c1 dot get area is. Okay, and then let's just have one more circle with -5. Okay, and let's just for the sake of simplicity, let's have under local variable c2. cd, and then I'm going to say except runtime, what did it find it as runtime error, and I'm going to say at this point except runtime error, I'm going to say print negative radius. Right. Okay, and let's see what happens now. Okay, so first thing, this is a good example in the sense that it connects our idea of raising an exception and catching that exception. So first thing, this piece over here is a point where if something goes wrong, I'm just going to say raise an exception. I'm just going to throw an exception. This is a point where I'm throwing an exception. I'm just throwing it. I'm just saying something went wrong, and here I'm just throwing an exception out. But if I'm throwing the exception, who does it go to? It goes to the point where whoever called actually set radius, which was being called from the init. But init, within the implementation of init, it has no ability to catch it. Remember, if this exception gets thrown, it comes back to init because that's the point where set radius was called. But init doesn't have anywhere in this implementation a try except block, right? So it doesn't have the ability to catch it. So init takes that exception that it gets, and it's just going to throw it again. It says, look, I have no ability to handle this exception, so I'm going to throw it back to whoever called me, whoever called init. Who called init? Well, the init has been called. The init has been called from right here. It is being called from here. So if you look at this code, when I call the circle, this is when I'm calling the constructor. This is when I'm calling the constructor. Okay, and again here, this is a point when I'm calling the constructor. So I have two places that I'm calling the constructor. Okay, and that exception which was floating around from set radius to init, and then init again throws it back inside this block of code. Okay, this block of code says, okay, look, if I get that exception, if that exception that got thrown earlier, and if I get it, I have some ability to catch it, and that ability to catch it is right here. Okay, so I've taken that problematic piece of code which is right here. I've taken a problematic piece of code and I've put it inside a try block. Okay, I put it inside a try block, and if it does get raised, I'm then going to call my except to catch it. This is the point where I catch that error and then give back something appropriately to the user, telling the user what is it that actually went wrong. Okay, so let's just run this. Let's just see that we can actually try this. So before I do that, let's not even first worry about the problematic piece here. Let's just comment it out just for the time being, and let's just run it the way it is. Alright, so if I run this, I get the area of a circle is 78.53981. Alright, this is fine because, and why didn't this get printed? This didn't get printed because, well, nothing was wrong. Everything was good. Everything was fine with my code. The exception did not get raised. Okay, let's see what happens if I turn this piece of code on now. And let's just turn this off. Okay, let's just concentrate on the second piece just for the time being. If I run this, and there you go. I have a negative radius because this piece of code did something. It raised an exception. That exception was floating around. At some point, the except block caught it. It caught it, and it responded back by saying that something was incorrect. Alright, so I hope this was really useful. I hope now you have some sense of how to put this idea of exceptions together. I highly recommend reading my lecture slides and then getting your assignment completed a little bit more nicely. So you still have a few more days waiting for your assignment to get completed. I'm seeing a lot of questions on Piazza that people are still using exceptions a little bit incorrectly. So I hope this video in some sense addresses that problem. Alright guys, thank you.